Ask someone to explain to me how you might average a set of numbers without adding them all up and dividing by how many there are. Only 2 people can do it? You're fired. No, just kidding. Aubrey.
In class last time we did the blocks, and what we did in our group, we made each number that was in the set, and then we set them all equal. So if we had 10 here and like 6 here, we would take 2 down and see if they're equal yet, and then take 1 over and make them equal so they're all the same size, and so that all the numbers were then equal, and that would tell us the average.
So generalize that. Here's a set of numbers. Here they are. It's a data set. Here's some numbers. What are you going to do with them?
Find out which number they all have in common, like I don't know how to generalize it.
Go ahead.
I kind of remember what we did.
Does she know what she's talking about?
Yeah.
All right. See if we can get this out.
I don't think mine's an easier way, but we, let's say we had 4, 7, 8, 3. So we take the lowest number, which is 3, and then we just grab the other numbers and put a block. Well, we put each number with 3. Okay, so we have 3, 5, 7, 9. So we take the lowest number, which is 3, and then we have all of them be 3. And then we take the remaining blocks, and put them in each group.
Okay. Okay.
That's what we did.
All right. Yeah.
If you're given an X amount of numbers, you would just divide up the numbers evenly amongst however many numbers you have. So say if you're given 5 numbers, you could say 1, 2, 3, 4, 5, each giving them 1, and then just divide those all up until your friend did the 0.
Okay. That's almost getting towards the traditional add them all up, dividing by the number, but it is different.
So this way is really long and tedious, but it works. If you take the largest number and you pair it up with the smallest number, and you start taking from the largest until they're both the same, you set them to the side and take the second lowest, and eventually you'll end up with a set of numbers that are kind of close to each other, another set that are kind of close to each other, and you just repeat the process until everything's even.
So keep taking off the big numbers and putting on the number, the amount you take off of the big number, put it onto the small number until what? Just keep doing that until all the numbers are the same. And then you've got what? The average of those numbers. Does that make sense? Now, that's something you should know in averaging numbers. But it also is important with one of our formulas that we have visited earlier, and that is for trapezoids. So here's my trapezoid. It's not isosceles, and I want to get a formula for it. Well, one of the things I could do is I could come over here and cut this little piece off right here and put it up there. Follow me? Then I'm going to come over here and I'm going to cut this piece off, and I'm going to put it over here. Now I'm back to Mama. I'm back to the mother of all formulas, the rectangle, right? And what was the formula for the rectangle? Length times width. Let's see if we can find out what the length and the width of these things are. What would the width be of this? What would we call this of the trapezoid? The width of our rectangle is what of the trapezoid? The height, right? So if under W I put H, right? Now, what is my length? Well, it's from there to there, right? But notice, I had 2 numbers. A long number, a big number, and a little number. And I took some off of the big one and put it onto the little one. I took some more off of the big one and put it onto the little one until they are both the same length. What do we call that? An average. So the length is just the average of the bases. So if this big long one was b sub 1, and this little one up here was b sub 2, How do we average two numbers? This is clear back to 3rd grade or so. What was the original way most of us were taught? Add them up and divide by how many? So b sub 1 plus b sub 2 all over 2. There's my average. The average of the bases times the height. Now that may not look exactly like what we saw before, but it better be algebraically equivalent to it. Does that make sense? Just another way of looking at it. Something that we might mention to you, particularly you secondary majors, is the place I cut that happens to be the midpoints of the legs. And if I connect the two midpoints of the legs, this right here is called the mid-segment of the trapezoid. So the definition of a mid-segment of a trapezoid would be the segment connecting the midpoints of the legs. And guess what? It's the same length as the average of the bases. Can you see that? So another formula for finding the area of a trapezoid would be the length of the mid-segment times the height. Because the length of the mid-segment is simply the average of the two bases. Does that make sense? Having multiple ways of getting back to a formula that we all know and love and have learned since 3rd grade is important. Being able to take students back in at least one way, but hopefully several ways. Anybody have a question about this approach? Okay. Let's go questions from the quiz then, quickly. Yes?
The parallelogram where it said 2 consecutive sides are 7 and 5.
Parallelogram. 7 and 5. Consecutive means they are together, right? Okay.
And then it said between the sevens, the other side was 4.
The distance between the sides that are 7 is 4. So that means this right here is 4. Okay. What have we got? What figure? Parallelogram. The area of a parallelogram formula is what? Base times height. What's our base? 7. What's our height? 4. Should have been 28. Oh.
I missed that. I thought
Okay.
so I put 28.
All right. So we got to read what's going on. Perimeter. How do you find perimeter? 7 plus 5 plus 7 plus 5, right? Or 2 times 7 plus 2 times 5. Or 2 times the quantity, 7 plus 5. There were several ways we looked at doing that as well. Yeah. So, all right. Just read the question, I guess, would be the best thing.
Yeah.
Anybody else? You know what's going on. You just don't know how to read, right?
Yeah, it makes me so mad.
Okay. But isn't that what we want to teach our students too? Is to be critical readers and to help them. Yeah, it should make you mad. When you know what and you miss it because of that. Yeah. Frustration. Anybody else? How about questions from the homework? Anybody quickly? The key should... Did you get my email? Rushing around to get out of here, I accidentally stuck the GeoGebra version of the assignment back in the previous... Did anybody see it back there and find it and use it? Some of you did. Okay. But anyway, it's there, and I've actually given you till later today for those of you, if you want to resubmit and regrade, that's okay. But you really should go in and spend some time with those little GeoGebra files. Or, by the way, if you want to do Sketchpad, it's on every computer in this lab right through the wall here. And you could just pop in there and do it there. That's another option. You can also download a free version that works for, I think, 30 days and does everything but save and print. But, yeah. Did somebody have a hand back there? Okay. All right. We've been talking about polyhedra three-dimensional objects, and we've been talking about how to find their volumes and their surface areas. And in class you build a rectangular prism, right? Do you know what I'm talking about? Out of the blocks. And I think you did a, was it a 2 by 3 by 4?
I forgot that part.
Huh?
I forgot that part.
Okay, we better do it. Better do it. Pull out some blocks. Everybody make a 2 by 3 by 4. Yeah, did we get, no, not everybody's got them. They don't articulate on all of the sides, but just, you should probably be doing this with a partner, not by yourself, so you can interact and talk. That's the best way to have kids work. It doesn't matter if you've got geniuses in your class that can do it with you by themselves. These blocks.
We good? Does anyone need us blocks?
How do we find the volume, first of all? If one of these little units represents a 1 cubic unit, how many cubic units are in our rectangular prism? I heard something. 24? How do we get it? But why length times width times height?
If we're going from what we had before, all it is a bunch of little 1 unit wide things. So where we had the rectangle before where it's length times width, I just have a bunch of rectangles stacked next to each other. And so I'm essentially multiplying how many of those rectangles I have.
Length times width times height. Why? He said length times width is what? What is it? It's our rectangle, right? So it's how many cubes are sitting on the bottom layer. Do you agree with me?
Yes.
If you went L times W, it's how many cubes are on the bottom layer. And the H tells you what?
How many layers?
How many layers? On bottom layer. And this tells you how many layers there are. So if the object goes straight up, every layer will have the same amount of blocks on it. And so all you got to do is take the amount on the bottom layer and times it by how many layers there are. We're going to give you a different way of saying how many are on the bottom layer. We're going to use a capital B. Capital B, when it's capital, we're going to have it mean base area. So if can I borrow yours? If yours is sitting like this, her base, if I tip it up, what's her base area right here? 12. If, however, it's sitting like, if it's sitting on, I gotta get somebody who's this stuck together. There we go. That base area is 12. So 12 on the bottom layer times 2 layers. Here, what if it's sitting like this? Now my capital B is how many? 8. Times how many layers? 3. I still get the same amount. What if I sit it like this? Now my capital B is 6 on the bottom layer times 4 layers. Doesn't matter how we go, but it's always base area times height. That will work for every single prism. And the definition of a prism is it's got a bottom base and a top base that are identical to each other and parallel to each other, and the sides are connected with either parallelograms or rectangles, or what we call prisms. Here is a hexagonal prism. How do I find the volume of this? The very same way. This is going to be the, if this was the mother formula for area, this is going to be the papa formula for volume. Because this is capital BH as well. It's just that my base now is what? It's what shape? It's a hexagon. But we know how to find that. We've had that, right? So I'm going to take capital BH, find out what the hexagon is. That's how many are on the first layer. And then I'm going to multiply by how many layers there are. It doesn't matter the shape of the base. If it goes up and hits another base that's the same size, that formula will work. In fact, this is not technically a prism, but it still works. This formula right here works for this. What's this called?
Cylinder.
Cylinder. What's the base called? Circle. So I find the base area, that's how many are on our first layer, and then I times it by how many layers there are. So this formula is very versatile. Very versatile. Okay? It works for this. Find the base area. This time it's a triangle, so I'm going to use the triangle formula. That'll tell me how many are on the bottom layer, and then I just multiply it by the height, which is the number of layers. Okay? All right. What about the surface area? How do you find surface area of these things? Anybody?
Apparently I'm fired again.
Can somebody tell me the surface area of their prism that you just built? The 2 by 3 by 4?
I always forget when the one off.
Should be like 52-ish.
You look at all the faces, every face, and add them.
You just take every face and find the area of each face and add them all together. One way of thinking about that would be to build a net. So, for example, if I had the, where did I put it? The hexagonal, there it is. If I had this and I wanted to find its surface area, I would find the area of this hexagon, the area of that hexagon. Actually, I'd find the area of one and times it by 2, right? Don't go through the process twice, that would be crazy. Then I would find the area of one of the lateral faces and times it by 6, and then add those two amounts together. Here's what this is what we call a net. Let's see, do we have anybody in here named Annette?
I was thinking
It's a good joke. It kind of reminds me when my daughter, who's named Hannah, when my oldest daughter had her first child, and they were always saying, "Yeah, and I'm going to be Uncle Paul, and I'm going to be Aunt Rebecca, and you're going to be Aunt Tana." If you make a net and then unfold the net is just a covering, unfold it, and now I have a two-dimensional surface. There's my 2 hexagons, there's my 6 rectangles, and add them all up. That's how you do everything. Okay? And so if we were to put contact paper on, or if we were to paint the outside of this cube that you just built, we would have to find the area of each of the faces and just add them up. And sometimes you can add them up more rapidly, like instead of going this plus this plus this plus this times 2, right? This times 6, and then add the result. All right. But what about if you get to something like this? What is it? Okay, if I were going to find the surface area of this cone, what would I do? Well, I would do the very same thing I would do as I did with this. Make a net. Okay? It's composed of what? A circle for the base, and what would you call that shape? A sector. Good, she's using the right words. A sector of a circle. But do we even know what the radius of the circle is, and do we know the angle? I'm going to draw it up here. It looks something like this, right? And you'll notice that if I fold this back, that this length here is what? It's the slant height. When you're talking about a cone, the height is the distance from the center of the circle to the apex of the cone, or the vertex of the cone. That's the height. If we take the distance between my fingers now, that's called the slant height. Why? Because it's slanted, right? And every other time we use H, even here, it's always what? Perpendicular. So when we use H for a cone, we're talking about from the center of the circle to the vertex. When we're going from here to there, it's the slant height. Okay, so slant height, we typically use the letter L. I don't know why, but every book I've ever taught out of does. That's our slant height. And what is this right here? It's an arc. How long is it?
Circumference.
It's the circumference of the base of the cone. Everybody see how when I wrap it around, it's just the circumference of the base of my cone. So I'm going to put a capital C down here. But we also know that a capital C means what? 2 pi r, or if we use d, we could get what? Pi d. Either one of those, right? So this, from this distance over to here, is 2 pi r or pi d. Well, how are we going to find the area of this quite irregularly shaped object? We're going to do like what you did for the circle. What did you do for the circle? You did do the circle, right? I've been gone, but I hope you haven't been gone.
Would you cut it so it looked like a triangle, so we would find the triangle and then find the rest?
Oh, so you're saying
Or is that just...
go like that,
Uh-huh.
have this triangle, and then find this. Who remembers the name of that? If this is a sector of a circle, what's this called? Segment. Well, you're good. That's a good idea. We have this measurement. We don't have this one. If we could do that, take the triangle plus the segment, we would have our entire thing. Great. Any other ideas? Well, let's try this. Instead of dividing it up this way, let's divide this up into a bunch of sectors. But if we were to make enough of these, right? If we're to make enough of these, this rounded part, if we let the number of triangles go to infinity, these sectors would turn into triangles. Because they would be close enough to each other that there wouldn't be any difference between, right now it's a little bit curved here, but the more we got, the more straight it would get. Does everybody follow what I'm saying? All right. So what we're going to do is we're going to divide this lateral surface area of the cone into a whole bunch of triangles. And when I say triangles, I'm going like this because they really do have a little bit of a curve at the bottom, unless we let the number go to infinity, in which they would all become straight, which is kind of mind-boggling. But so let's just say that the distance from there to there is b sub 1, and the distance from there to there is b sub 2, b sub 3, etc. over here until we get to this one, and that's b sub n. You with me? All right. So, how would I find the area of this triangle? Well, let's use the triangle formula. What? 1/2 the base times the height. What's the height of this one? L. Right? Going right up the middle, that's L, correct? So does everybody agree that that's the area of this triangle right here? What would the area of the next one be? 1/2 base sub 2 h, right? And if we did this for all the way over and added them up, found the area of the first triangle, the second triangle, the third triangle, the fourth triangle. If n is infinity, we could add them up to infinity. And we've added all of these. Do you agree with me that the area of all those triangles would be the area of the lateral surface of our cone? You with me? All right, let's do a little algebra. Anybody see any common factors in these terms we can factor out? Anything that they all have? 1/2. Let's take it out. Anything else? This is b sub 1, this is b sub 2. Those are different things. We do have the, I was putting h. It's L for our, it's height for the triangle, but L for our, so we will factor out an L. What's left in this term? B sub 1 plus, what's left in this term? B sub 2 plus B sub 3 plus dot 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 plus B sub n. Everybody with me? But what is this in parentheses? It's a summation of all the bases, which is this plus this plus this plus this plus this plus, which is really what? The circumference of the base. That's what we just said, right? So guess what I'm going to do? I'm going to take this out and put in circumference. So 1/2 LC. But we know that C is simply 2 pi r, right? So let's go 1/2 of times L times 2 pi r. Everybody see what we've got? Let's simplify it. Can we? What? 2 times 1/2 is 1, right? And that leaves us with L and a pi and an r, and we typically write it pi r L. So what is this? It is the lateral area of a cone. So, here we go. Now I've got a cone here. This is 3. This is 4. I'd like you to find the total surface area. Total surface area. Total surface area, here we go. You'd make a net. right? What have we got? A circle and the lateral surface area here, right, which we now have. So can we find the area of the circle? What?
135
What is the formula for a circle area? That's
Pi
perimeter.
squared.
Pi r squared. So pi and r is 3 squared. There's our circle area. Now all we've got to do is the lateral area. Lateral means what? We need to know this word. Lateral. Come on, you football players. If the quarterback tosses a lateral, what is he tossing? He's tossing it out to the side. Lateral is the English word that means side. Not in math. It's not a math word. It's an English word. It means side. So the side area around the side is what? It's pi r l. So we're going to add that in. Pi, what's r? 3. And what's l?
5. Sorry.
Is L 4?
Is the 4 your height of your cone?
It is.
So then it's 5 is your lateral.
4 goes from the center on up.
What we need.
We need this. So what? 3 squared plus 4 squared equals L squared, right? There's our, so what do we do? 9 plus 16 equals L squared. That's 25 equals L squared. So L must be 5. So this times 5. So we've got 9 pi plus 15 pi, which is what? 24 pi. That is, if you're going to paint this, you would need, we could figure this out. We could go 24 pi times 3.14 and get an approximation. That would give our total surface area. We would know how much paint or how much contact paper we needed. Is everybody okay on this? Can you... We took this back to the triangle, which goes back to Mama, right? So even the lateral surface area of our cone goes back to Mama. Has to go through the triangle to do it, but... Anybody have questions about this?
When we get the answer, do you want us to do 24 times pi, or do you want us to leave it at 24 pi?
This is the exact answer, so it's actually more accurate.
Okay, so you do.
I don't mind if you want to put your little approximately equal to sign and then put something that you round off to an appropriate length,
Okay.
but I don't need you to.
Okay.
Okay? But if we were going to paint, if this was 3 feet and 4 feet, and we were going to paint this, you might want to do that to see how many square feet there are, so that when you go buy your paint, you could, yeah. Pi doesn't tell you, but that's when you might want to do that.
Okay.
Anybody else have a question? All right. Let's get you this and investigate some other things about volumes. Again, working with a partner, please. Did everyone get one? Okay. Use your cubes, follow the directions, talk to your partner, and fill this out. The pyramid's not coming to a point, it's going straight up. If it comes to a point, we call it a pyramid. If it goes straight up, we call it a prism. So this is a prism. It has the very same base, right? But it goes straight up.